Hello everyone, this is Steve. If I want to graph these two functions here, g of x and q of x, then I need the original 2 to the x function and the original log base 2 of x function. So the original 2 to the x function has 3 key ordered pairs on it. It has -1, 1/2, 0, 1, and 1, 2. And therefore, its inverse function, log base 2 of x, has those exact same 3 ordered pairs swapped on it. So 1/2, -1, 1, 0, and 2, 1. Now I can use that information to work with these functions here. G of x is an altered version of the 2 to the x function, where this minus sign right here causes us to reflect over the x-axis. This -1 right here causes me to add 1 to every single x value, and this -3 here causes the whole graph to shift down 3 units. So what I need to do is I need to adjust my ordered pairs accordingly. So the first thing I'm going to do is I'm going to add 1 to every x value. That's going to be 0, 1, 2. Then, because of this minus sign here and this -3 here, I change all the y values to negatives and then subtract another 3. So if you change 1/2 to a negative and then subtract 3, you get -3.5. If you change 1 to a negative and then subtract 3, you get -4. And if you change 2 to a negative, you get -2, subtract 3, you get -5. And those will be the points that I plot to get my new graph. With the logarithm graph over here, because of the -3 on the inside, we're just going to shift the whole graph to the right 3 units, which means I'm just going to add 3 to every single x value. So if I add 3 to every single x value, I'm going to get 3.5, 4, and 5, and then the y values don't actually change on this one. Okay. Let's plot our points to get our graphs. So I'm going to plot g of x first here. So we'll first order pair 0, -3.5. So that's going to be right there. Next order pair 1, -4. That's going to be right here. And the next ordered pair is going to be 2, -5. So that's going to be right here. What happened, everyone, the most crucial thing to understand here is the whole graph shifted down 3 units after it was flipped. So our horizontal asymptote is actually right here, and the graph was flipped over. So now this is what the graph looks like with a horizontal asymptote of y equals -3. The domain hasn't changed. The domain is still -∞ to infinity, but the range for this sucker is going to be -∞ up to -3, not including -3 because we don't reach the asymptote. Okay, let's graph the logarithm one over here. So 3.5, -1. So they come out 3.5, go -1, and then 4, 0. So 1, 2, 3, 4, 0. And then 5, 1. So what happened here was the whole graph shifted 3 units to the right, and with that, the vertical asymptote that was right on the y-axis moved over, and now it's here at x equals 3, so this is our logarithm graph. And while the range to this graph is still -∞ to infinity, the domain on this graph has changed. The domain of this graph is now going to be 3 to infinity, not including 3, because that's where the vertical asymptote is. Okay, I hope that helps. Thanks for watching.